Very good morning, students. This is Dr. Eustace Russell, working as assistant professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far we are discussing the subject called Robot Dynamics and Control, subject code RA3601 under the regulation of 2021. So far we completed Unit 3, first two parts successfully completed. Last class we have seen about various motors, servo motor, stepper motor. So various characteristics we have discussed in the application, why it is coming under open loop system and a closed loop system also we have covered. Now in this part 3 video, again we are going to see the continuation of those parts. This slide give a glimpse of the syllabus already we have seen in the first part of this video lecture, that is a unit called robot control system. So now we are having another important concept that is called sensors, robot sensors. Sensors are devices for sensing and measuring geometric and physical properties of robots and the surrounding environment. That is called sensor. Why the sensor is needed means, so without sensor, so we can't see any obstacle that is passing over there. So sensor is important one. So for the robot, without sensor, very difficult to operate. So various sensors we can classify based on that. We have the, so what are the important parameters you have to look onto that to make a sensor? That is position, orientation, velocity, acceleration, then distance and size is there, then force, moment is there, temperature, luminance and weight. These are the important parameters should be taken into account. I will repeat once again: position, orientation, velocity, acceleration, distance, size, force, moment, temperature, luminance and weight. Desirable features of sensors, that is accuracy. Accuracy should be high. How close output to the true value is the accuracy of the device. What is the true value of this? It is give the accuracy of the device also. The precision, there should not be any variations in the sensed output over the period of time. Precision of the sensor should be high. Operating range, sensor should have wide range of operation and should be accurate and precise over this entire range. That is the operating range, which have a wide range of operation that should be accurate and precise over this entire range. Speed of response, should be capable of responding to the changes in the sensed variable in minimum time. Sensed variable in minimum time. That is nothing but it represents the speed of the response. Calibration, sensor should be easy to calibrate time and trouble required to calibrate should be minimum. It should not require frequent recalibration. That is called calibration. Reliability, it should have high reliability. Frequent failure should not happen. Cost and easy of operation, cost should be low as possible. Installation, operation, maintenance and should not require skilled or high trained person. That is cost and easy of operation. So every time we are installing something means, so cost is the important thing. So we have to maintenance, operation maintenance should not be more than that. So it will be a normal economic cost, then it is easy of that operation. So robotic sensors, we can see one basic classification, that is static sensor and the environmental sensor. Static means force, position, velocity, acceleration. Environmental sensor is nothing but motion, force, torque and touch and tactile. Then contact sensors, force, temperature and the pH. Non-contact sensor, that is vision, optical, range and chemical. Now the number of advanced sensor technologies that may be used, we can see in this table. Sensor type, that is tactile sensors, used to determine where contact is made between the sensor and the other object. Two types: touch sensor, which indicate when contact is made and no more, and the force sensors will indicate the magnitude of the force with the object. Then proximity sensors used to determine how close an object is to the sensor, also called a range of a sensor. Then optical sensor, photocells and other photometric devices that can be used to detect the presence or absence of objects, often used in conjunction to proximity sensors. Machine vision, used in robotics for inspection, part identification, guidance, and other uses, that is termed as machine vision. Others, miscellaneous category of sensors may also be used, including devices measuring temperature, fluid pressure, fluid flow, external voltage current, and other physical properties. So in this, that proximity sensors, optical sensors, these are the very important things. That is called a range sensor, proximity sensor. Optical means in order to any obstacle there, it will measure and inform that to avoid that hitting with that objects. Then range sensor, ranging sensor including sensor that require no physical contact with the object being detected. That is ranging. Ranging means, as I already told, that is proximity sensor. So that is coming under the second category is optical. Whenever the obstacle is there, we can see. The proximity is mostly the meant for ranging. That is, we can see the how much range the robot can operate, which can provide the details. They allow a robot to see an obstacle without actually have to come contact into it. This can prevent possible entanglement, allow for better obstacle avoidance, and possibly allow software to distinguish between the obstacles of different shapes and sizes. There are several methods used to allow a sensor to detect obstacle from an object. Light-based ranging sensors used multiple methods for detecting obstacles and determining range. The simplest method uses the intensity of the reflected light from an obstacle to the estimate distance. So like that reflected light method, we can see how much the object that is there, what are the objects that is present in front of that path, we can see that. However, this can be significantly affected by the color and the reflectivity of the obstacle and the external light sources. If I see the color and the reflection of the obstacle, it can identify what are the objects that is in front of that. A more common method is shows a beam of light projected at an angle and the strip of detector spaced away from the emitter as in the animation to the right. The pictured sharp sensor uses this method. This method is less affected by the color and the reflective of the object and the ambient light. Like that, here we can see LIDAR, a more advanced method of range detection, use a laser that is up across the sensor's field of view. The reflected laser light is usually analyzed one of two ways. One with longer ranges, sometimes actually determine distances by measuring the time it takes for the laser pulse to return to the sensor. So another method uses the phase shift detection to determine range by analysis the incoming light and the reference signal. Working principle, we can see the triangulation. Use the triangle formed by the traveling path of the signal to calculate the distance, the time of flight. Use the time of flight of the signals to measure the distance. Typical range sensors, that is infrared range sensor, triangulation, ultrasonic sensors, time of flight, laser range sensor, that is triangulation, ultrasonic sensors emit a quick burst of ultrasound, that is 50 kilohertz, human hearing, that is 20 hertz to 20 kilohertz. Measure the elapsed time until the receiver indicates that an echo is detected. Determine how far the nearest object is from the sensor, that is D equal to Vt, T equal to round trip distance, and v is the speed of propagation, that is 340 meter per second. That is time you can see. That is the elapsed time we can measure it. Then the next slide gives a glimpse of, that is, tactile sensors provide the robot with the capability to respond to the contact forces between itself and other objects within its work volume. Tactile sensors divided into two types: touch sensor and the stress sensor. Touch sensor are usually simplified to indicate whether the contact has been made in an object. Whether you are touching the object, we can sense now, just like that. By touching only, we can see whether the object is there or not. Simple servo switch can serve the purpose of the touch sensor. Stress sensors are used to measure the magnitude of the contact force. How much the magnitude of the force that is acting over there, we can measure that also. Strain gauge devices are typically employed in the force measuring sensors. Potential use of robots with tactile sensing capabilities would be in assembly and inspection operation. In assembly, the robot could perform delicate part alignment and joining operation. So mainly in assembly usage industries, it can delegate the part alignment and the joining operation. In inspection, touch sensing would be used in gauging operations and dimensional measuring activities. Then proximity sensor. Proximity sensor are used to sense when one object is close to another object. On a robot, the proximity sensors would be located near or apart from that end effectors. This sensing capability can be engineered by means of optical proximity devices, eddy current, the magnetic field sensors, detectors, and other devices. In robotics, proximity sensor might be used to indicate the presence of a work part or an object. This could also be helpful in preventing injury to the robot human co-workers in the factory, because when the sensor is there, we can avoid accidents. Then the last slide of this part 3, we can see optical or infrared, both name are same, optical or infrared light based sensors. Now we are going to see, this is the one of the areas that is receiving a lot of attention in robotics research. Computerized visual system will be an important technology in future automated factories. Robot vision is made possible by means of video camera, sufficient light source, and a computer program to process image data. The camera is mounted either on the robot or in the fixed position about the robot, so that its field of vision includes the robot work volume. Work volume already is seen in the unit 1, that is workspace which the robot is working. The computer software enables the vision system to sense the presence of an object and its position and orientation. Visual capability would enable the robot to carry out the following kinds of operation: retrieve parts which are randomly oriented on the conveyor, recognize particular parts which can be intermixed with other objects, perform assembly operation which require alignment. Another very popular method uses projected light waves, usually infrared, or to detect obstacles. This system projects a pulse of light and looks for the reflection. The properties of the reflected light are analyzed to determine characteristics about the object detected. Light has the advantages of traveling extremely fast, allowing for fast sensor response time, high resolution, and the less error to account for. Light from this type of sensor is often formed into a narrow beam, or many times a laser is used. This provides good resolution over large distances. So these are the references which I used for preparing this content. Kindly go through this content. Thank you, students, for your kind attention. So kindly go through the references and prepare well. Kindly subscribe this channel and share this video to your friends. So we will meet in the upcoming video lecture of part of unit 3, that is part 4. Thank you.